Hello gems, welcome back after a long time. So in this video we'll be discussing all the maths that you'll ever need for physics. Okay, so often in our discussion of physics we require some results from maths, we need some elementary knowledge of math, right? So that is exactly what we are going to target in this video. So in this video we'll be studying about trigonometry, differentiation, integration, geometry, algebra and logs and graph. Vector is also a major part which will be covering up in the next video. Okay, so for today's video we'll be targeting this 4 things. Okay, so this video is perfect for all the levels of class 11th and 12th. Okay, may it be for boards or your any competitive exams like JEE Main, BITSAT or NEET. Okay, this is especially helpful for those medical students who don't have any math background. Okay, also I'll recommend that each of you should prepare your own notes during this class because a lot of results are going to come your way. Okay, so you just have to note them down and you'll have to use them in future. Okay, so yeah, let's begin our journey of math today. Thing on our list is trigonometry. Here are some general results from trigonometry that we'll be using quite often. So let's go through them. So the first one is theta. If theta is the angle, it can be expressed as length of the arc by the radius. Okay, this is something we discussed in units and dimensions also as supplementary physical quantity. So next one, 180 degrees corresponds to pi radians. Okay, this is basically used for convergence. Okay, so if you have an angle in radians and if you want to convert it in degrees or vice versa. Okay, if you have a angle in degrees and you want to convert it in radians. Okay, so these are some common angles that we'll be using. Okay, so you should remember the both forms, the radian form and the degree form of the angle. So 90 degrees is basically pi by 2. So you can divide this equation by 2 on both the sides. So you'll get 90 degrees is pi by 2. Then pi by 4 will be 45. Again you can divide this by 2. So pi by 4 is 45. So 60 degrees is basically pi by 3. You can divide 3 on both the sides. So here you will get 60. Okay, 180 by 3 is 60. Okay, so here pi by 3 is 60 and similarly pi by 6 is 30. Okay, so suppose if we have 15 degrees, okay, and you want to convert it in radians. So what is this in radians? Okay, so the conversion is very simple. Okay, let me show you how. Okay, so we are going to use basically this relation. Okay, so 180 degrees corresponds to pi radians, right? So if you have 15 degrees, how many radians? Okay, so this is simple math. Okay, you just have to cross it over. Okay, so x will be given as 15 times of pi divided by 180. Okay, so x will be given as 15 pi divided by 180. So you can actually cancel this, 15 1s are 15 and 3 carry, 15 2s are, right? So pi by 12. Okay, so 15 degrees is nothing but pi by 12. You can also see this is 30. If you divide 2 on both the sides, pi by 2, 15, right? So yes, 15 degrees is pi by 12 in radians. Okay, so this is how you can convert. Okay, so if you were given this as pi by 12 and if you were asked what is it in degrees, okay, you can also use this as x and again cross over and solve for x. Okay, so that is how you convert between degrees and radians. Okay, now let's come to this one. This is very basic. You might have studied it in your lower classes. Okay, so here we have a right angle triangle. This is theta, which is the angle under consideration adjacent to theta, this side. Opposite to theta is this side, and this is the hypotenuse, the longer side. Okay, so sine theta is defined as opposite side upon hypotenuse, opposite upon hypotenuse. Cos theta is adjacent, the adjacent side, adjacent to theta upon hypotenuse. Tan theta is opposite upon adjacent. Okay, now the other three ratios are basically the reciprocal. So sin theta, so cosec theta is the reciprocal of sin theta. So you can see the flip over. Okay, so cosec theta is hypotenuse upon opposite. Okay, you can see the flip over, right? Sec theta is reciprocal of cos theta, so it will be hypotenuse upon adjacent. Okay, cot theta is the reciprocal of tan theta, which is adjacent upon opposite. Adjacent upon opposite. Okay, let's come to the fourth one. Here 3 simple identities which you would have learned in your lower classes. Okay, so first one is very simple, sin square theta plus cos square theta is 1. Okay, then we have a little bit different ones. Okay, so 1 plus tan square theta is sec square theta and 1 plus cot square theta is cosec square theta. Okay, so of course there is a derivation behind this. We are not going to go into the proofs of this we are just going to describe the results, okay, or discuss the results that we are going to use, okay. So that is the aim of this video, okay. So I'll also give you a trick to remember this. Now sin square theta plus cos square theta is equal to 1 is very simple, right? Let's come to this too, okay. Now you can remember t to s, okay, t to s. So if you add 1 to t, that will give you s. That is how you are supposed to remember. So 1 plus tan square theta t is equal to sec square theta, and here 1 plus cot square theta is equal to cosec square theta, and here you also remember c to c so that you don't mix in between these two, okay. So 1 plus tan square theta, 1 plus tan square theta t is equal to sec square theta, and 1 plus cosec square theta, 1 plus cot square theta t, right? 1 plus cot square theta is cosec square theta, and c for c, okay. So you don't mix up with this two, okay. So that is done. Let's come to the fifth one. Fifth one is sine a plus b. So if you have sine of a plus b, okay, a and b are two angles, 30 degrees, 60 degrees, suppose, okay. So sine of a plus b will be sine a cos b. Now for sine, the ratio is, the answer is for a plus b, it is sine cos, of the format sine cos cos sine, sine cos cos sine, okay. So sine a cos b plus cos a sine b, okay, plus for plus, okay. For cos you will see it becomes opposite, okay. For plus you will have minus, for minus you will have plus. So you can compare and study, okay. So I know this is confusing, so that's why I asked you to note all of this down, okay. So sine a plus b is sine a cos b plus cos a sine b. Now sine a minus b, you don't have to do anything, just have to change the sign in between, okay. So sine a cos b minus cos a sine b, okay, very simple. Now sine 2a, you can actually derive this by just substituting b as a. So sine 2a will be sine a cos a sine a, or 2 sine a cos a, okay. Excuse me. So that is how you do it, okay. So that is the result, and please remember the result instead of substituting it over there. It's very simple, right? The result that you get is very simple. Now let's come to cos. Now for sine, the answer was of the form sine cos cos sine. For cos, the answer is of the form cos cos sine sine, cos cos sine sine, and it is inverse, I shall say, like the sign will be changed. For a plus in between, you'll get minus, okay. So let's do it. Cos a plus b will be cos a cos b minus sin a sin b, okay. The sign will change, okay, and cos is cos cos sin sin, okay, and cos a minus b will be cos a cos b plus sin a sin b, okay. The sign will change. For sin, the sign will be same. For cos, the sign will change, okay. And similarly, cos 2a you can find by substituting a over here. So this will be cos a sin a sin a. So that is cos square a minus sin square a. Yeah, cos 2a is basically cos square a minus sin square a. You can also find it in terms of cos and sin only. So for that, you are just supposed to use this first identity. So if you want it in terms of cos, substitute sin square a as 1 minus cos square a. Okay, so all of your terms, all of your answer will be in terms of cos. Okay, so it is 2 cos square a minus 1. When you substitute this as 1 minus cos square a. Okay, and if similarly if you want in terms of sine, you can substitute cos as 1 minus sin square a. Okay, and that will give you the answer in terms of sine. Among these three forms, the second one in terms of cos is the one that is most important over here. Okay, so these are few results from trigonometry. We have more to discuss on trigonometry. So let's move to them. You can pause the video here and take a screenshot or make a note of this formula. Okay, so let's move. Discuss this table. Here we are given the values of sin theta, cos theta and tan theta for different angles. So if you want to read this table, so you can read that sine of 60 degrees is root 3 by 2. Okay, so that is how you are supposed to read this table. So here you are supposed to know all these values by heart. We are going to use these values frequently. Okay, you are expected to know the values of cos 60 by heart. Okay, all these values. Okay, so let's go through the table. Okay, you might have your own ways of remembering. Okay, so you can use any hack. Okay, provided you remember all the values in this table. Okay, so sine of 0 is 0, cos of 0 is 1, tan of 0 is also 0. Okay, you can remember that tan is sine by cos. Okay, so if sine is 0, tan will be naturally 0. Okay, now sine of 30, sine 30 is half, cos 30 is root 3 by 2, tan 30 is 1 by root 3. You can take the ratio sine by cos. Okay, this will be verified. Okay, then sine of 45, sine of 45 is 1 by root 2, cos of 45 is also 1 by root 2, and tan of 45 is 1. Okay, you can take the ratio You can see both are equal, so 10 is 1. Okay, 10 of 45 is 1. Now let's come to 60 degrees. Okay, here also I have mentioned the angles in radians. Okay, so you might, in certain cases you might be given as sine of pi by 2. Okay, you are supposed to remember that pi by 2 is 90. Okay, so sine of pi by 2 or 90 is 1, sine 90 is 1, cos 90 is 0, and tan 90 will be infinity, sine by cos, right? 1 by 0, infinity, or undefined. Okay, then sine of finally this angle, okay, which is added maybe to your 10th standard list. Okay, this was not there in 10th standard, I am guessing. Okay, so sine of 180, okay, sine of 180, sine of any multiple of pi. Okay, this is 1 pi, right? 1 pi, 2 pi, 3 pi, any multiple of pi is 0. Okay, so sine pi is 0, or sine 180 is 0, cos 180 is minus 1. Okay, and 10, okay, so if sine is 0, 10 will be naturally 0, right? Because it is sine upon cos, right? So sine is 0, 10 is 0. Okay, so yeah, this is the added one. So sine 180 is 0, cos 180 is minus 1, and 10 180 is 0, since sine is 0. Okay, you can also produce the cosec theta, sec theta from this. Okay, because you know that basically cosec theta is the reciprocal of sin theta. So if I ask you for cosec of 45 degrees, so cosec of 45 will be reciprocal of this root 2, right? So you can produce those values, so you should not be concerned about them. Anyways, we are not going to use that much of those values. Okay, and this is a special triangle that you are supposed to remember. Okay, this is the 37-degree triangle. Okay, so here if you are asked for sine of 37, so basically it is the triangle 3 4 5. Okay, and 3 is opposite to 37, that is what you are supposed to remember. Okay, so it is a right angle triangle 3 4 5, 3 is opposite to 37 degrees Celsius. Okay, so if you are asked for sine of 37, you will say it is 3 by 5. Okay, you may be asked for cos of 53 also from this triangle. Okay, cos of 53 will be 3 by 5 again. Okay, adjacent upon hypotenuse. This is opposite upon hypotenuse. Tan of 53, tan of 53 is opposite upon adjacent. So 4 by 3. Okay, so this is a special triangle that you should remember. 3 4 5 and 37, or 3 is opposite to 37 degrees Celsius. Okay, so let's discuss a final thing about trigonometry, and you can note this table down for now. You can take a screenshot or make a note of it. Okay, two results from trigonometry. Okay, then we'll study the graphs and do some questions on trigonometry. Okay, so here in the 8th result we have all students take coffee. You might have heard of this phrase. Okay, why are the students taking coffee? Okay, so basically this is a phrase to remember which ratios are positive in which quadrant. Okay, so this is the first quadrant, this is the second quadrant, third quadrant, fourth quadrant, right? Your basic coordinate geometry. Okay, so this is x-axis and this is y-axis. Okay, positive x, positive y, negative x, right, negative y. Okay, so this is first quadrant, second, third and fourth. Okay, so all students take coffee is a phrase that is used to remember which ratios are positive in which quadrant. Okay, so in the first quadrant it says all. Okay, so all the ratios, sine, tan, cos, cosec, all the 6 ratios are positive over here. Okay, in the first quadrant. Okay, let's come to the second one. It says students. Okay, so S. Okay, S is for sine and cosec. Okay, since sine is positive, so S is for sine, so its reciprocal will be also positive, right? So if sine is positive, cosec will be also positive. Cosec is the reciprocal of sine. Okay, so S is for sine, sine is positive, meaning cosec is positive. Rest all the others, okay, all the others are negative in the second quadrant. Tan is negative, cos is negative, cot is negative, others. Okay, sec is also negative. Okay, only these two are positive. Then in the third quadrant, take. Okay, all students take. Here all are positive, here only sine and cos. Okay, sine and cos. Now take is for 10. Okay, T for 10, right? So 10 is positive, meaning reciprocal will be also positive, which is cot. Okay, so in the third quadrant, tan and cot are positive. Only tan and cot are positive. Okay, so sine is negative, cos is negative, your cosec is negative, and sec is also negative. Okay, in the third quadrant. In the third quadrant, only this. In the second quadrant, only this two. Here all are positive. Okay, Now finally coffee, C for cos. Okay, so cos is positive and it's reciprocal, sec is also positive. Okay, so here this phrase, all students take coffee, or you might have heard different versions of it, all silver teacups, whatever. So this phrase is used to remember what ratios are positive in which quadrant. First quadrant, all are positive. Second quadrant, students, so S, so sine and its reciprocal, cosec is positive, rest all are negative. Take T, 10 and its reciprocal, cot is positive, rest all are negative. Coffee, C, cos is positive, its reciprocal, sec is also positive, rest all are negative. Okay. Now this is what we are going to use to solve this type of questions. Okay, so what is sine 90 plus theta? What is sine 180 minus theta? What is tan 90 plus theta? Okay, so we are going to find the answers to this, and remember that when the angle is 90 degree, so if it's 90 degree plus something, the ratio will change. Okay, 90 degree or a multiple. Okay, multiple of 90, like 90, 270, 93 is 270, right? And you can have multiples of 90 basically. Okay, so either 90 or any multiple of 90 will change the ratio. Sine will become cos, tan will become cot, sec will become cosec. Okay, you'll come to know when we do these questions. Okay, and for pi or 180, the ratio will not change. For 90 or multiples of 90, the ratio will change, and for 180 or pi, the ratio will not change. Okay, so let's understand what this means. Okay, so what will be sine of 90 plus theta? Sine of 90 plus theta. Okay, so you can clearly see that it will be in the second quadrant. So 90 is this, right? This angle is 90 degree, 90 plus theta in the second quadrant. Okay, so sine of 90, 90 ratio changes for 90, right? Sine will become cos, okay, so cos. Now cos, in the cos, and you can simply write theta. Okay, this 90, you just have to look for the sine. Okay, so basically you can replace sine by cos. Okay, and simply write theta and then look for sine. Okay, so as I said, 90 plus theta will be in the second quadrant. In the second quadrant, sine is positive. Okay, so basically sine of something will be positive of cos. Okay, so it will be cos theta. Okay, so once you get your answer, okay, here it is 90, so I changed it to cos. Okay, no need to write that 90 now, because 90 simply change the ratio to cos. Okay, sine will change to cos, and you can omit that 90 now. Okay, next thing is to change for check for sine. Okay, so cos of theta, will it be positive or negative? So check for sine. Okay, so 90 plus theta, so 90 is this, theta is this. Okay, 90 plus theta in the second quadrant. In the second quadrant, sine is positive. Okay, check for the sine of this. Okay, not the sine of cos. Cos will be negative over here. Okay, here you are supposed to check the sine of the ratio on the left hand side. Okay, let's do it 4 times. Okay, 4 times or 3 times more. Okay, so that you get the hang of it. Now sine of 180 minus theta. Sine of 180 minus theta. So when it is 180 or pi, ratio will not change. Okay, ratio same, 180 or any multiple of pi. Okay, pi, 2 pi, 3 pi. Okay, any multiple of pi, ratio will not change. Okay, so 180, 360, whatever ratio of pi. Okay, so that time the ratio will not change. Sine will remain sine. Okay, sine will remain sine, and you can simply write theta. Now next thing, check for sine. Check for sine by the quadrant. So 180 minus theta. So this is 180, right? Straight line, right? 180 degrees. So this is 180 degree minus theta. Okay, 180 minus theta. So minus some theta, right? So 180 minus theta. So that will lie somewhere in the second quadrant. 180 minus theta. Second quadrant. So second quadrant, sine is positive. Okay, so basically it is plus sign. Okay, so here also it is plus, here also it is plus. Okay, so sine is plus in the second quadrant. Let's come to tan of 90 plus theta. So tan of 90 plus theta. So here first of all you can see it's 90, so the ratio will change to cot. For tan it is cot. Okay, sine cos, tan cot, sec cosec. Okay, so the ratio will change to cot theta. Now you can see the angle lies in the second quadrant, 90 plus theta, right? 90 plus theta. Theta you can, it's generally acute. Okay, acute. So it will be not greater than 90. Okay, so the your angle will be somewhere in the second quadrant, right? 90 plus theta. So in the second quadrant, tan is negative. Only sine and cosec are positive. Tan is negative, So here minus sign will come. Okay, 10 is negative. Let's do the final one now. You can do it yourself. Okay, comment the answer in the comment section. Okay, now I'll do it. Okay, you can pause the video and try it for yourself. Okay, sine of 180 plus theta. Now 180 pi ratio remains same. Okay, ratio will remain same, sine will remain sine. Okay, and simply you will have to write theta. Okay, so now 180 plus theta will be in the third quadrant, right? So this is 180 plus some theta. Okay, 180 straight line plus theta. Okay, 180 plus theta. So in the third quadrant. In the third quadrant, only 10 is positive. Take, right? All students take 10 and cot is positive. Rest all are negative. Sine, so sine is negative. So sine is negative. Okay, so let me check those. So we get cos, sine, minus cot and minus sine. Yes, that's correct. Okay. So finally, let's bring our attention over here to this ninth result. Okay, I hope this was clear. Okay, this is something that we'll use often. Okay, you can rewind the video and watch this again if this was not clear anytime. Okay, so let's come to the final point over here. So sine of minus theta is minus sine theta. Okay, so sine of minus 30, you can say it is minus sine 30. Okay, so you can get the minus sign outside. Basically, sine is an odd function. Cos of minus theta is cos theta. Okay, so it digests the minus sign. Okay, it is a even function. Okay, so yeah, and then you can say 10 of minus theta. Basically, you can take the ratio and prove it that 10 of minus theta is minus tan theta. Okay, so basically these two are important over here. Sin of minus theta is minus sin theta, and cos of so if you have cos of minus 30, it is same as cos of 30. Amazing, right? So cos is a even function. Okay, so let's finally discuss about the graphs and do some problems, and then we'll move to our next topic, which is differentiation. Finally discuss about the graphs. Okay, then we'll take on some questions, and then we'll move to our next section, which is differentiation. Okay, so here we have the graphs of sin x, cos x, minus sin x and minus cos x. Okay, so you are supposed to remember the general curve. Okay, you can also plot it remembering the values. Okay, I'll show you how. Okay, this is something that we'll need for SHM chapter 14 of 11th standard. Okay, so let's go through them. So the graph of sin x is basically this wave. Okay, this wave. You can see that sin 0 is 0, sin pi by 2 is maximum, which is 1. So maximum value of sin and cos is 1. Okay, value wise it's 1. Okay, and if you see sin pi is 0, I told you that at multiples of pi the function becomes 0, right? Your sin function pi, 2 pi, 3 pi function will become 0, and it is maximum at pi by 2, 3 pi by 2, 5 pi by 2. Okay, so like that. Okay, so here we have so sin 0 is 0, sin 90 or sin pi by 2 is 1, maximum value. Again sin pi is 0, sin 270 or sin of your 3 pi by 2 is minus 1. Okay, these are higher values which we didn't discuss in the table, and sin of 2 pi, which is 360, is again 0. Okay, for multiples of pi, sin function is 0. Okay, then let's come to this one. Here we have cos x. Okay, cos x, if you remember, cos 0 was 1. Okay, so it starts at a higher point. Okay, so it starts at the maximum. Cos 0 is 1, then cos 90 is 0. Okay, so if you see, these are the values that are decreasing. Okay, so sin cos 0 is 1, then we have the values are decreasing, right? Cos 45 is 1 by root 2, something less than 1, right? So the values are decreasing. Finally at cos 90 it becomes 0, cos pi minus 1. Okay, so cos pi is minus 1, cos 270 or 3 pi by 2 is again 0. Okay, so you can see the multiples of pi by 2. Okay, odd multiples of pi by 2, the function becomes 0. Okay, your cos function. And finally cos 2 pi is again 1. Okay, cos 0, 2 pi is 1. Okay, then let's come to sine of minus x. So basically you can see it's flipped over, right? It's the mirror image, I can say, not mirror actually. Okay, so it's flipped over. Okay, so the positive portion is shifted to the negative, and negative is shifted to the positive. So that is what is happening. Otherwise, if you see, the values are the same, only the signs have changed. Okay, sin 0 is 0, sin pi by 2, here it was 1, right? Sin pi by 2 minus 1, because here there is a minus sign. So sin of pi by 2 is 1, and this minus sign, minus 1. Okay, so basically the values are the same, but the signs have changed. Here also values are the same, the signs have changed. So the positive region becomes negative, negative region becomes positive. Okay, so that is how you can remember it. Sine is a wave, cos is a wave starting from maximum, sine is a wave starting from 0 again. Okay, simple wave starting from maximum again, and sine minus, you just flip this over, positive negative, flip this over, positive negative, minus cos. Okay, so that is done. So those are the general graphs. Let's take on some questions now. So in the first question, you are given that sine of some angle theta in a right angle triangle is 1/4. You are supposed to find cos theta and tan theta. Okay, how will you do this? It's very simple. Sine theta is defined as opposite upon hypotenuse, right? So opposite is 1 and hypotenuse is 4. Okay, in the simplest ratio. It can be also 4 and 16. Okay, so if you take the ratio 4/16, it's also 1/4. Okay, but in the simplest ratio, it is 1 and 4. Okay, so let's find this x. How will you find that x? Okay, you just have to use Pythagoras theorem. Very simple. So 4 square hypotenuse square is a square plus b square, right? So 16 minus 1 is x square, so root of 15, right? So this x is nothing but root of 15. Okay, now you have the value of this x. Now you can easily find cos theta. Cos theta is adjacent upon hypotenuse, so root 15/4, and tan theta will be nothing but opposite upon adjacent, right? So 1/root 15, opposite upon adjacent, opposite to theta upon adjacent to theta. Okay, so you found cos and tan theta. Okay, so simple use of Pythagoras, and then find cos and tan using their definition. Now tan of 210. Okay, so this is something we just learned. Okay, so you can write 210 as 180 plus 30. Okay, why am I writing like this? Because either here I want a multiple of pi or pi/2. Okay, 180 or 90. That then only I can decide whether the ratio will change or will it remain same, right? So that is the logic that I'm using. So I'm splitting it as 180 plus 30. Okay, so cos 10 of 180 ratio remains same. Okay, ratio does not change. So 10 will remain 10 and 180 plus 30. So 180 is this, right? 180 is straight line, right? So 180 is on your protector, 180 is this. Okay, and plus theta, 180 plus 30. Okay, so somewhere in the third quadrant. Okay, so this is third quadrant, right? This is the second one, this is the first one. Okay, and this is the fourth one. So 180 plus 30 in the third quadrant. Third quadrant, 10 is positive, right? So first of all, write simply 10 30, right? And then decide sign based on this. Okay, so 10 of 30, 10 30 is 1/√3, right? Then sine of 300. Sine of 300, you can either write it as sine of 360 minus 60, right? Or you can write it as sine of 270 plus 30. Because 270 is a multiple of 90. Okay, 90 into 3 is 270. Okay, odd multiples. Okay, that is a keynote. Okay, odd multiples of pi/2. Okay, so 270 plus 30. So odd multiple, then only the ratio will change. Odd multiple of pi/2, then only the ratio will change. Okay, so sine will become cos, right? And simply write cos 30 and then decide the sign. Okay, sine will become cos, right? 270, it is 90 into 3, multiple of odd multiple of pi/2 or odd multiple of 90. So the ratio changes to cos 30. Simply write 30. Now decide the sign. So 300 is, so if you see this is 270, right? So by the way, this is 90, this is 180, this angle is 90 degree, this is 180, this is 270, and plus 30 somewhere over here in the fourth quadrant. In the fourth quadrant, cos is positive. No, you are supposed to look for sine, right? So here, okay, look for the left hand side. Okay, so sine is negative. Okay, so here answer will be negative. Don't make such mistakes. Okay, look for sine. Okay, sine is negative of cos 30. Cos 30 is, sine 30 is half, cos 30 is √3/2. Okay, so this minus sign and √3/2. Okay, so that's your answer. Let me check that. It's 1/√3 and minus √3/2. Yes, that's correct. Let's move to differentiation now. That's all from trigonometry. Discuss our topic number 2, which is differentiation. So before we directly hop into the standard differentiations and solve it, okay, let's first interpret what does it physically mean. What does differentiation mean? Okay, so suppose if you have a curve like this, okay, so a function is plotted over here, okay, you can see the curve, okay, you choose 2 points on that curve and draw a line on it. Okay, now you're supposed to find the slope of this line. So how is slope given? Slope is y2 minus y1 upon x2 minus x1, right? So you can basically write it as delta y by delta x, y2 minus y1 upon x2 minus x1, right? So delta y by delta x, okay? Now what is differentiation? Differentiation is basically when this point comes very close to each other. Limit, you can see that limit delta x tending to 0, okay? So this difference becomes very small, okay? It comes to a limit form, okay? So if you bring this, if you keep on bringing this point very close to this point, okay, if you keep on bringing the point number 2 very close to point number 1, at a certain point what will happen, okay, in the limits, what will happen is that this line will become tangent to the curve, okay? What is meant by tangent? Tangent is basically a line which only intersects the curve at one point, okay? Here the line is intersecting at 2 points, right? So it is a chord, okay, and in this case it is tangent. It is only intersecting at one point. The diagram is shabby, but for a tangent, the tangent only intersects the curve at 1 and 1 point, okay? So this is a tangent. So basically when you bring the point very close, okay, what will happen? This line, which is a chord, will become a tangent, okay? And derivative is nothing but the slope of that tangent, okay? So this definition, okay, so when delta x tends to 0, so this distance become very small, okay? So this distance becomes very small. The point 2 comes very close to point 1. So in the limit delta x tends to 0, this difference becomes very small. So the line will become a tangent to the curve, and the slope of that tangent is nothing but your derivative, okay? So that is the physical meaning of your derivative, and it is written as dy by dx, okay? Since the change is very small, right? So change in x is very small, and with respect to that the change in y will be also very small, okay? So often the small changes are written as dy by dx, and the big changes are delta y by delta x. Here when delta x tends to 0, delta y will be also very small, so dy by dx is change in y with respect to x, and its physical interpretation is over here. It is the slope of the tangent to the curve at that point, okay? Slope of the derivative is the slope of the tangent to the curve at a point, okay? So that is what derivative is. So let's hop into the standard derivatives now. Let us now study this table of differentiation. Here you are given different functions like constant function kx, x to the power x, sin x, other functions, okay? And you are given the derivatives of this function, okay? So you can derivate this function, and what is the derivative of this function. Of course you can derive this using the first principle. The math peeps will be doing that, but it's of no concern to us. We are just going to use this as standard results, okay? So this is something that you are supposed to remember, so note it down. So let's begin. So first we have a constant function, okay, k, okay? So suppose y is equal to, you are just supposed to picture this as y is equal to k, okay? So y is equal to k, or y is equal to suppose 2, okay? So y value is not changing, so the derivative will be of course 0, right? Because derivative is nothing but slope of the tangent, right? So delta y by delta x, so y is not changing, so delta y is 0, so slope is 0, so of course the derivative will be 0. Of course this one was easier. Now of course I cannot give you the logic for the other ones. This were derived using the principle. So just go with me, just remember this. So now if you have slope of kx, okay, the derivative of kx, okay, so you are supposed to differentiate d by dx of kx. You can write it this way, okay? So dx by dx, that is 1, so kd. So your answer to this, the derivative of kx, will be nothing but k, because this is 1, okay? So answer is k. Now the derivative of x to the power n, okay, the n comes down and the power reduces, n comes down and one power reduces. So suppose you have x to the power 2 and you want to differentiate this, so d by dx of x to the power 2, so that will be 2 will come down, x 2 minus 1, 2 minus 1 is 1, okay, or x to the power 1 is simply x, right? So this is how you differentiate it. So x to the power 3 will be 3x 3 minus 1. 3x 3 minus 1 is 2. So 3x square. Okay. So sin x, the differentiation, the derivative is cos x. Cos x, the derivative is minus sin x. Okay. So remember that whenever you have c, okay, in trigonometric ratios, there will be a minus sign popping up. Okay. So sin x is cos x is minus sin x, c minus sin. Okay. Here we have 10x, 10x will be sec square x. Okay. Then cos x will be c is there, so there will be a negative sign. Of course, the results are not that intuitive, but you are supposed to remember it. Okay, so cos x is minus cos x cot x. Okay, so you can compare and study. 10 you can study the relation sec square x. So similarly, cot and cos x square x. But c, so minus sin. Okay, so that is how you can study. Sec is sec x 10x. Okay, so you can compare it with this. Okay, so that way you can study. E to the power x, this is the exponential function, so e to the power x will be e to the power x. Okay, e is a number, okay, basically it's 2.71828, and that you raise to the power x. Okay, so that is called exponential function. So the derivative of that function, it is a very special function, the derivative is the same. Okay, and even the integration, as you will see, is the same. Okay, so plus c, of course. And now let's discuss this sum results. Okay, this will be used when we are solving problems on derivative. We'll be doing that next. Okay, so if you have derivative of u plus v, two functions u and v. Okay, so you can split the derivative of u plus derivative of v. Okay, so suppose you have 2x and plus e to the power x. So you can take the derivative of 2x, then take the derivative of e to the power x, and then x. Okay, simply means that. Now suppose you have two functions multiplied to each other, 2x into e to the power x. Okay, so you will have to take u into derivative of v plus v into derivative of u. Very easy to remember, right? U into derivative of v plus v into derivative of u. Easier form is this. Okay, usually suppose you have dy by dx, it is denoted by y dash. Okay, so if you want to write the derivative of a quantity, you can simply write v dash. Okay, v dash will be dv by dx. Okay, so u into derivative of v plus v into derivative of u, uv rule it is called. Okay, and this is u by v rule. Okay, u by v, not v square. Okay, so it is u by v rule. So here it is a bit complicated, so follow me up. So here the denominator will be squared. Okay, so denominator squared. Okay, that same function will come over here, not squared. Okay, here denominator squared, same function comes over here. Don't square it this time. Okay, in the numerator, no squaring. Then into derivative of the first function. Okay, the derivative of the numerator minus, now flip this over. Okay, u will come out derivative of v. Okay, and in between there is a minus sign. Let's do that once more. So if you have, this is called the quotient rule. Okay, u by v, right? So u by v will be v square in the denominator. Okay, so the function in the denominator, you will have to square it. Okay, same function you bring it over here, okay, without squaring, into the derivative of the function in the numerator. Okay, minus, flip it over. Okay, v, bring u out and take the derivative of v. Okay, so that is what we are going to do. When you solve it, it is going to look simpler. Okay, when you have functions in your hand, it is going to look simpler. And finally, chain rule, which is which I can show you only by doing. Okay, suppose like if you have dx by dt. Okay, usually we differentiate, suppose we have dy by dt. Okay, usually we differentiate with respect to x only, but you might be asked to differentiate with respect to t, like acceleration and all. It's rate of change of velocity, dv by dt, or your velocity itself is rate of change of position, dx by dt. Okay, so those times you can, if you don't know the derivative, you can write it this way. Okay, so dy by dx into dx by dt. Dx can cancel, and simply you get dy by dt. Okay, so if you don't know dy by dt, you can find dx, dy by dx. Okay, so if the function is given in terms of x, you can find dy by dx and simply multiply dx by dt. Okay, so you'll come to know more when we do such type of problems. Okay, so you can note the standard integrals over here, we are going to use it. So let's go to the questions now. Solve some questions based on derivative, what we just learned now. Okay, then a final concept of maxima minima, and then we'll move to our third topic. Okay, so here you are given a function y. Here your objective is to find y dash in all of these questions. Okay, so find y dash over here. So simply it is dy by dx, right? So here you are supposed to find dy by dx of this whole thing. So actually you have plus and minus sign in between, right? But I said you can split, right? So you can, if you have x cube plus 5x square, so you can split the derivative, right? You can take the derivative of x cube, then take the derivative of 5x square, right? And then add all those derivatives, and finally the derivative of 2 over here, okay? So you can split the derivative between plus and minus sign, okay? So now this is of the form x to the power n, right? X to the power n. Do you remember the derivative of it? N x raised to n minus 1. The power comes down and reduces by 1. So 3 will come down, x, 3 minus 1, that is 2, right? 3 comes down, n minus 1. So 3 minus 1, 2. Okay, here we have 5x square. Okay, 5 is constant. Okay, constant in multiplication, it can come out. Okay, constant is multiplied by x square, so it won't have any difference. So you can just remove out that constant, okay, out of the derivative sign, and the derivative of x square, okay, that you can again use this rule, that will be 2x, right? 2 will come down, 2 minus 1 in the power, 2 minus 1 is 1, right? So simply 2x, okay. And here we have derivative of 2, okay, derivative of 2 is 0, right? 2 is a constant, derivative of a constant is 0. Here 5 was a constant, but it was multiplied to x square, okay. So if you have kx, you can remove the k, remember? So you can remove the k and then differentiate that, okay. So yeah, so constant in multiplication will survive, constant which is simply there will die, okay. So it is 3x square plus 10x, 5 to the 10, okay. Let's come to this one. Here you will have to use the product rule, uv rule. So u into v, you can see two functions, u into derivative of v plus v into derivative of u, okay. So y dash will be just dy by dx, okay. So this is u, so you'll use u into derivative of v plus v into derivative of u. So u is your x, okay, u is x, v is sin x, right? So u into derivative of v, sin the derivative of sin x, okay, I'll do it step by step, plus v, which is sin x, into derivative of u. So derivative of x, which is itself dx by dx, which is 1, right? So here x, derivative of sin x minus cos x, no, cos x, okay. Derivative of sin x is cos x. Minus sign will only come if there is a c, okay, for trigonometric ratios, plus sin x. Okay, so x cos x plus sin x. So u into derivative of sin x, which is cos x, so sin x into derivative of x, which is 1, dx by dx, 1, right? Let's come to this one now. For this one, we have to use your quotient rule, right? This is of the form u by v, okay, u by v. So y dash, which is dy by dx, is given as, basically if you remember, it was v square, then bring the same function up, u dash, u and v dash, okay, just flip over, okay. So now the function in the denominator is to be squared, same function, bring it on top, okay, then the derivative of the function in the numerator, which is x, minus x, you bring it out, and the derivative of sin x, okay. I hope you were able to follow that. It's very simple. The derivative, the square of the function in the denominator, you can write this way or this way, means the same. Sine is a ratio, right? It's something 1 by 2, 2 by 3, okay. So it's a ratio, so you can either write sine x the whole square or sine square x. It's the same thing, okay. So the square of the term in the denominator, bring that same term over here, okay, multiply it by the derivative of the numerator, minus, flip it over, okay, derivative, bring this out and take sin x in, okay. So now solve it. So dx is 1, right? So here we will have sin x minus x into derivative of sin x is cos x, right? And here we will have sin square x, okay. So this is your answer, this is your y dash, okay, simply that. So for 4 and 5 we have to use the chain rule. So let's do the 6th one first, okay. So this is something I told you. So here you are supposed to find dy by dt, okay. So dy by dt can be easily found. You can write dy by dx, since your function is function of x, right? So you can write dy by dx into dx by dt, Okay, so dy by dx you can find surely, right? It is just y dash. So what is the derivative of d by dx of 3x cube, right? And also we have dx by dt. This dx by dt will remain separate. Okay, so here you'll have 3 can come out and you'll have derivative of x cube and dx by dt. That dx by dt will remain in the answer. Okay, so the derivative of x cube, if you remember, it was 3x square, right? 3 comes down, x to the power 1 power less, x square, right? So 3x square and dx by dt. Okay, so it is 9x square dx by dt. Okay, so simply it's the dy by dx into dx by dt. Okay, you can write it that way. Okay, now let's come to this. This applies your chain rule. Okay, so you have to think about it. Okay, so think about it. So here we have function in terms of a function. Okay, function composed in a function. If you have learned composition of functions. Okay, so here if you see, it is of the type x raised to something, right? Or something raised to your power. Okay, something raised to your power 6. Okay, so it is of the form x to the power n. Okay, so it will have the same differentiation. Okay, same form you have to use, but again you have to go inside that bracket and then differentiate again, and then the results you just have to multiply. Okay, I'll repeat. It is of the form something raised to power, right? Something raised to your power 6 or x raised to n. So it is of this form, right? So of course there is something extra, but it is of this form basically, right? There are some constants over there, but it is of basically of this form. Okay, you will use the same form. Okay, same answer, but you will just go into the bracket and then differentiate again. I'll show you how. Okay, so first what you are supposed to use, you are supposed to use this. Okay, so this is your x now. Okay, this is your x, this entire thing. So what will happen, the power will come down, power comes down, 6 minus 1, right? N x raised to n minus 1. This entire thing is your x now. So 6 minus 1, that is 5. Now you have to go inside the bracket. Go inside the bracket and differentiate this. Okay, so differentiate 2x plus 3. 3 is a constant, differentiation 0. Differentiation of 2x, differentiation of kx, k, right? So basically 2x, if you differentiate, what will happen, 2 will come out, and dx by dx, right? So basically this is 2. Okay, so that 2. Okay, so once you differentiate this of the form, this is of this form, you differentiate it and then go into the bracket. So that is what you do in chain rule. So 6 to the 12, okay, and 2x plus 3 the whole raised to 6. Now let's come to this one. You can try this one on your own. Okay, this is of the form sine of something, right? Sine of something. Then you have to go into the bracket, differentiate. Then again differentiate. Okay, here we will use 3 times because e to the power something is also very complicated. X square, right? Not simply x. Okay, so you can see this is sine of something, right? Sine of something. Okay, sine. What is the derivative of sine? Cos. So cos of that very same thing. Okay, so first you keep that same thing as it is, right? So you just see sine of something. So cos, the derivative of that is cos of something, right? Now you go inside that bracket. Go inside that bracket. So e to the power something, right? Now it is of the form e to the power something when you go inside the bracket, right? E to the power something. So what is the derivative of e to the power something? E to the power something, right? E to the power x, the derivative is e to the power x. So yeah, e to the power x square, the derivative is e to the power x square. You just have to multiply the derivatives. Okay, that is the chain rule. And finally this is x square, right? Now you have to go in this bracket, the bracket on top. Okay, so that is also something, right? So that is x square. X square derivative is 2x. You can easily remember, power comes down, 2 minus 1, that is 1. So this is 2x, you can write it more properly, x square into e to the power x square. Okay, so this is your answer. Okay, so you just have to go inside the brackets. Okay, you can see sine of something. So the derivative will be cos of the something. Okay, then you have to differentiate that something. That even if that something has more something like this, e to the power x square. So again differentiate that. So go inside, inside, inside. Okay, so that is how you apply the chain rule. Okay, so that's those are the questions on derivative. Let's study a concept which is based on this derivative, which is maxima minima, and that will be the end of differentiation. Let's study the concept of maxima and minima. So here you can use your knowledge of derivative to find the maximum, local maximum and local minimum of a function. So here we have a function, as you can see. So as you can see, when the function reaches its maxima and minima, basically the slope is 0, right? Because the line is flat. Slope is also given as tan theta. Okay, so if the angle made with the x-axis, if the line is parallel to the x-axis, then tan of 0 is 0, right? So basically the slope of this line and the slope of this line is 0. Okay, so these are tangents at the maximum point and tangent at the minimum point. You can see that at the maximum point and the minimum point, the slope of the tangent to the curve is 0, which means the derivative at the maximum and the minimum point is 0. Okay, so dy by dx is 0 at critical points or at maxima or minima. Okay, these are called critical points. Okay, maxima or minima. So how do you tell whether the function is maximum or minimum at a point? Okay, so for that you have to take the second derivative. You have to derivate the function again. Okay, so you derivate it once, equate it to 0. Okay, so that will be your critical point. That will give you a point where your function is maximum or minimum. You can't tell whether it is maximum or minimum. For that, in order to tell whether your function is maximum or minimum, you will have to take the double derivative, differentiate the function again. Okay, so when you differentiate again, the answer that you get is negative. Your function is maximum. Okay, local maximum. And if the answer that you get is positive, it is minimum. So it's kind of opposite. Okay, so if you get negative, maximum, positive, minimum, second derivative. Okay, so you can also wire the logic for this. Okay, you can see that so basically second derivative, you can imagine it as the derivative of the next point. Okay, almost the very neighborhood point. Okay, so you can see the derivative of this point will be a line like this, right? A slope of the line like this, slope of the tangent like this. Okay, so the tangent is like this, going down, means the slope is negative, or it is making an obtuse angle with the x-axis, so the slope is negative. Whereas if you see, so here the slope is negative. Okay, so for max the slope is negative of the next point. Next point is the second derivative. You can imagine it that way. And for this, you can see that the tangent is going up, positive slope. Okay, so for that the function should be minimum. So the function was minimum over here, and just on the next point the slope is positive. Function was maximum over here, just on the next point the derivative is negative. Okay, so that's why it's opposite. Okay, so negative for max and positive for minimum. You can directly remember this. Okay, no need of that logic. Okay, here you are supposed to find, so let's do a question now. So in this you are supposed to find the maximum value and or the minimum value. Okay, maximum or the minimum value. Okay, so let's find y dash first. Okay, because dy by dx is 0 at maximum, at critical point, at maximum or minimum value, right? So let's find dy by dx first, and we'll put it equal to 0. Okay, in order to find the point at which the function is either maximum or minimum. Okay, so 25, now you can remove it out, right? You know the constant in multiplication, you can just remove it out. 5 is a constant, differentiation of 5 will be 0. Again 10 you can remove, and dx by dx, right? So 25, and here you'll have 2x, which is differentiation of x square is 2x, 2 comes down to minus 1, right? And here you'll have 10. Now you'll equate this to 0 because you want to find at what point your function is maximum. Okay, so this will be 25 into 250x, and you can take this 10 to the other side, so x will be nothing but 1 by 5, right? So x is 1 by 5. So at 1 by 5 your function is either minimum or maximum. Okay, it's either minimum or maximum. Okay, in order to check that, you'll have to find the second derivative. Second derivative, how will you find? Just differentiate this function now. Okay, now what is that you obtained? This is the first derivative, right? This is dy by dx. You can differentiate it again. Okay, so differentiate it again, so that will give you d2y by dx square. This is the higher derivative. So again, so you can say it is 50x minus, so basically it is 50x minus 10. Okay, so if you differentiate this, this is of the form kx, derivative of kx is k, right? So it is 50 and this is 10. 10 is a constant, derivative of that is 0. So the answer that you get is plus 50, right? Plus 50. This is positive. So positive meaning your function is minimum. Positive second derivative meaning your function is minimum. Okay, now okay, so function is minimum. So let's find the minimum value. Okay, so y minimum, so basically you have to substitute this point. Okay, so at this point your function is minimum. This was just to verify whether the function is maximum or minimum, because you don't know. This is the test for checking whether your function is maximum or minimum. So minimum y will be given when you substitute x is equal to 1 by 5. Okay, so 25 into 1 by 5 square plus 5 minus 10 into 5. Okay, 10 into 1 by 5. Okay, so this is 25 and 25 will get cancelled. 1 by 5 is 25, so this will be 1. This will be 5 minus this will be 2. I guess this is 4, right? Yes, so the minimum value of y should be 4. Yeah, that's correct. Okay, so that's the concept of maxima and minima. You will just equate the first derivative 0, find the point at which your function is either maximum or minimum, find the second derivative to verify if the function is maximum, to find whether the function is maximum or minimum, and then substitute this value to find the maximum or the minimum value. Okay, so that's about maxima minima. Let's move to our next topic, which is integration. Now study about integration. So just like derivative or differentiation, your integration also has some physical meaning. So suppose this is your graph. Okay, this is some plot of a function. Okay, so integration is nothing but it will give you the area under the curve. Okay, so you can also imagine it. So it is for a small thickness d, the function, the value of the function almost remains constant, suppose. So for small distance, okay, dx, so small change in x, the value of the function will almost remain constant. Let us say it to be y. Okay, so basically the area of this rectangle, now we can shade this rectangle, this will be given as length into breadth, right? So length into breadth, so length is y, right? This length is y and breadth is dx. Okay, so length into breadth will give you the area of the shaded region. Now you can integrate this over this interval to obtain the area under the curve. Okay, so you can just add the different rectangles in this area one by one to get the entire area under the curve, right? You can go from A to B and find the area under this curve from A to B. Okay, so that is what integration is. Okay, so basically this is length into breadth and you just integrate it. You just add the areas of the rectangle. Okay, so basically you divide this areas into area of rectangles, small rectangles, very small. Okay, and then you just add those areas. Okay, actually those rectangles are very fine. Okay, actually there are infinite number of rectangles. Okay, so that is the idea of your integration. Okay, so the physical meaning is integration will give you the area under the curve, whereas differentiation gives you the slope of the tangent to the curve, right? So now here we are given some standard integrals. Of course the list is very big, but we'll constrain ourselves to those which are really important. Okay, so these are the ones that will come out in physics. Okay, so the results are slightly trickier. Okay, so slightly confusing when you compare it to derivatives, so pay close attention. Okay, so here we have functions and here we have their integrals. Functions, integral, function, integral. Okay, so now coming to x to the power n. Okay, the integral of this is x n plus 1 upon n plus 1. So power plus 1 divided by power plus 1. Okay, and plus c always comes when you integrate it indefinitely. Okay, when you don't specify this a and b, the limits. Okay, so if you don't specify the limits, the c will always come. C is basically a constant. Okay, it is called the constant of integration. Then we have 1 by x. 1 by x is log x. Okay, So previously if we discussed, I don't know if we discussed this, but the differentiation of log x is 1 by x. Okay, log to the base ex. Okay, the differentiation of ln of x or log to the base e, you'll get to know what this is 1 by x. Okay, and the integration of 1 by x will give you log of x. So basically integration and differentiation are opposite processes. Okay, so if you have integration of differentiation of x, okay, this will basically give you x. Okay, so if you integrate and differentiate a function, it will give you the same function. Integration and differentiation are opposite. Okay, because if you see derivative of ln of x is 1 by x. Okay, I think we didn't discuss this, but remember that the derivative of ln of x, you can add it to that list, is 1 by x, whereas the integration of 1 by x is ln of x. Okay, so they are completely opposite processes. Okay, now the integration of sin x is minus cos x. Okay, now here where the confusion starts. Okay, so integration of sin x is minus cos x. My teacher used to give us methodologies to remember this. Okay, so I still remember this. So sin of x dx. So integration is written like this. So she used to say this is a snake and this is a snake. So two snakes make it as poison, and so this is cos of minus x. I know this is cringe, but I somehow remember this and I think it was helpful, right? So integration of sin, so these are like two poisons, so that poison is minus sin. Okay, so that is minus cos. Okay, and integral of cos is sin, simply sin, not minus sin. Okay, plus c, of course, the constant of integration. Integration of kx, so if you have something like k dx, okay, dx is always there. Without dx the integration does not make sense. Okay, so you can remove the k outside and integration of dx will be nothing but x. Okay, so it is kx plus c. Okay, of course there is constant of integration. Now finally e to the power x, very special function, derivative same, integration also same, but only the difference is constant. Okay, so e raised to power x plus c is also x plus c. Okay, now definite integral. Okay, so when you are specified this limit, okay, when you are integrating over two limits a and b, you are given those a and b. Okay, so suppose you integrate f of x and you get g of x, just like if you integrate 1 by x, you will get ln of x, any other function, right? So if you integrate this function, the integral of this function is g of x. Okay, so just like sin x is minus cos x, so you get minus cos x. Then you just have to, in order to find the definite integral, okay, this will give you a value or a perfect answer. So you just have to substitute the upper limit and subtract the lower limit. So in place of x, you will put the upper limit minus in place of x, put the lower limit. So upper limit minus lower limit. So that is for definite integration. You will come to know when we solve problems. Okay, so I just hurried through it, but when we solve problems, you will get a clear picture of this. So let's do some problems now. Problems on integration, and let's wrap up this topic. Finally, we have some small topics left, which is geometry, algebra, graphs and log, okay, which are very simple. Okay, so let's wind this up first. Okay, so you are supposed to integrate this over here. Okay, so again integration can be split among different terms. So you can find the integration of 5x square as this. Okay, 5 can be taken out, then you can take 3 out and then integrate x dx, again take 2 out and integrate dx. Okay, so you can do it this way. Okay, you just splitted up the integral. Okay, now this is of the form x to the power n. What is the integral of that? This is the common one, we are going to use this a lot. So n plus 1 upon n plus 1, right? So x to the power 3 upon 3, right? Just add 1 to the power divided by 1 to the power, right? So 2 plus 1, 3. Okay, now let's come to this one. X will have x square by 2, right? 1 plus 1, 2, 1 plus 1, 2. Okay, minus integration of dx, x. Okay, so if you integrate dx, small dx, you get x. Okay, let's come to this one. Now this is a trickier one. This is of the form, if you see 1 upon something, right? This is 1 upon something. So the answer should be ln of it, right? Because if you remember the integration, okay, the integration of 1 by x is ln of x, right? So this is 1 upon something, so the integration of 1 upon something is ln of something. Okay, also in integration here you are supposed to divide the constant. Okay, in case of differentiation we multiply. Suppose if we have 2x plus 5, right? We solved one such problem. Okay, we wrote the differentiation of this as this. Okay, first we used this is x to the power something, right? It is of that form, so we differentiated like this. Then we went inside and wrote the differentiation of this. Okay, so you write the differentiation of 2x, 2. You multiply 2, right? In case of your integration, you divide. Here the coefficient of x is 4, you divide that. Okay, or there is one more simple trick which you can use over here. Usually this type of problems are not significant in physics. Okay, but we might use it somewhere. Okay, like in LR and CR, I guess. But yeah, so let's solve it. So you can substitute this denominator as 4x plus 5. Okay, first of all realize that this is of the form 1 upon something, right? So that's something, you put it as t. Okay, now differentiate it with respect to x. Dt by dx is so 4x, the differentiation of 4x is 4, right? And phi is a constant, so so 4x, kx is k, right? So dt will be you can take this dx to the other side, 4 dx, right? dt will be 4 dx, or actually we'll write dx is dt by 4. Okay, because here in the equation we have dx, right? So we'll substitute everything in terms of dt. Okay, dt and t. So here in place of dx we can put dt by 4. Okay, that 4 we can take out, and in place of this we have substituted it as t, right? So this is t. So what is dt by t? Integration ln of t, right? ln of t, and you get it, t is nothing but 4x plus 5. Okay, so this is one more way of doing it. Let's come to this one. This is the definite integral now. Okay, so let's solve it. So what we are supposed to do, first integrate and then substitute the limit. Definite integral is very simple. Okay, so 0 to pi by 4, integration of sin x is cos. Okay, let's integrate it directly. Okay, integration of sin x is minus cos x, mind you, and cos x is plus sin x. Okay, and in each of this case, I'm so sorry, we'll have plus c plus c. Okay, this is indefinite integral. I'm so sorry. Yeah, so you'll have plus c everywhere. Okay, here you won't have plus c because it is definite integral. Okay, so integral of sin x minus cos x is sin x. Okay, now you're supposed to substitute the limit. Let us write it as sin x minus cos x first. Okay, just for simplicity, and then upper limit minus lower limit. So upper limit will substitute, minus lower limit will substitute in this bracket. So upper limit, substitute pi by 4 wherever there is x. So sine of pi by 4, sine of 45 is 1 by root 2, also minus sine here this bracket, right? Upper limit we are substituting. Cos of pi by 4, again 1 by root 2, right? Sine of pi by 2, pi by 4, and cos of pi by 4, 1 by root 2, 45 basically. Okay, and then substitute 0. Okay, don't be under the impression that when you substitute 0 everything will be 0. No, cos of 0 is 1. Okay, remember that. So sine of 0 is 0 and minus sine over here, and cos of 0 is 1. So this is 0, right, and this is minus and minus, that will give you 1. Okay, so the answer over that is 1. Okay, so yeah, that's our answer. That's how you do integration, and there will be no plus c over here. When you integrate with limits, there is no plus c. When you integrate without limits, there is plus c. Okay, so that is the point to remember. And let's move to the minor sections, which is geometry, algebra, and logs. Okay, so that will be done very quickly. So let's move to those now. Discuss about geometry. In this, we are going to discuss about some shapes and their areas, and some shapes and their volumes. Okay. So let's begin with them. Here are some shapes with their areas. Okay, so first is a square, side square, right, or a square. Okay, Then rectangle, length into breadth, area. Triangle, the area is basically given as half base into height, right? Then trapezium, if you have the area is given as, here it's a bit complex, but you just have to look out for the sum of the parallel sides, okay? So a plus b and the distance between them into d. So half a plus b into the distance between them, half the sum of the parallel sides into the distance between them. Okay, so that is how you find the area of a trapezium. Circle, pi r square, simple. Parallelogram, it's made up of two triangles, you can say. So it's base into height, right? So 2 times this, so base into height. Sphere, surface area, if you want to find, it is made up of, you can say, 4 circles, so 4 pi r square. Your CSA of your cylinder, okay, the curved surface area of a cylinder will be 2 pi r h. Okay, so basically you can imagine that it as stacked of circles. Okay, cylinder is nothing but you have stacked circles, right? So the circumference is 2 pi r and the height is h. So the surface area will be 2 pi r times h. Okay, the number of circles stacked. Okay, that will be given by the height. Okay, so 2 pi r h. Okay, so that will give you the curved surface area of cylinder. Ellipse, it's basically pi ab. Okay, pi a and b are the semi-major and the semi-minor axis, okay, of the ellipse. Okay, so if you have ellipse over here, so a is this distance, okay, semi-major axis, and b is this distance from here to the center, okay, from here to vertex and from here to vertex. Okay, so a pi into a into b, that is the area of ellipse. Cube is made up of 6 squares. Okay, the total surface area of the cube will be given as 6a square. Okay, a square 6 times. Okay, now let's come to the volume of some important shapes. So slab is usually in rectangular form. Okay, so basically it's length into breadth into height. Volume, right, meter cube, so length into breadth into height. Okay, so that will give you the volume of the slab. Cube, basically all the 3 sides are equal. It's just like a slab, but all the 3 sides are equal. So a into a into a, or a cube. Okay, then sphere is 4 upon 3 pi r cube. Okay, that is the volume of sphere. Cylinder you can imagine again as stacked circles. Okay, so one circle has area pi r square. So you are stacking circles up till a height h, right? So pi r square times h, pi r square times h. That will be the volume of that cylinder, pi r square times h. Cone is 1/3 of your cylinder, so 1/3 pi r square h, okay, of the same radius and height. Okay, so cone is 1/3 pi r square h. Now if you are given a quantity, okay, you are supposed to find the percentage error in that quantity. Basically the formula is q final minus q initial upon q initial into 100%. Okay, so these are basically values. Okay, so you make some measurement and suppose this is 3 centimeters, this is 2 centimeters. So 3 minus 2 upon 2, final minus initial upon initial into 100%. That will give you the percentage error in the measurement. Okay, and this is the distance formula. So if you have 2 points P and Q, okay, and this has x1, x2, x1, y1, z1, and this has coordinates x2, y2, z2. The distance between them is simply given as x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square and the square root of that. Okay, so that is the distance formula. So that is about geometry and some coordinate geometry. Yeah, that's all about it. You can solve question, you can just take the values of radius, but that is pointless to solve questions of such type. Just remember this formula, I would say, and let's move to the next section now. About algebra. Now this is very simple. These are some identities that you might have learned in your lower classes, so let's just brush up through them. So first one, we have a plus b the whole square, which is a square plus 2ab plus b square. A minus b the whole square is also a square minus 2ab plus b square. If you subtract this from this, okay, so this and this will add, other terms will get cancelled, so you will get 4ab. Okay, then we have a square minus b square, that can be factorized as a minus b into a plus b. Okay, then third one, we have a plus b the whole cube, that can be written as a cube plus 3a square b plus 3ab square plus b cube. Okay, and if you have a minus b, you just have to alternate the signs. Okay, a cube positive, this minus, this positive, this negative. Okay, so again write the same terms but alternate the signs. Okay, plus minus, okay, or you can substitute in place of b minus b. Okay, here if you substitute minus b, it is square. Okay, so it doesn't work. Okay, so it stays positive, and here when you substitute negative b, it will become minus b. Okay, or you can write the same terms and plus minus. Okay, that way also you can do. Now fourth one is a cube plus b cube. That can be factorized as a plus b into a square minus ab plus b square. Okay, so here if you have plus, here it will be minus. Here if you have minus, here it will be plus. Okay, so this is a factor of this. Okay, so a cube minus b cube, one factor is a minus b, the other factor is a square plus ab plus b square. When this is minus, this is plus. Okay, now the roots of quadratic equation, this is the quadratic formula. So if you have a quadratic equation like this, is ax square plus bx plus c equal to 0, then the roots will be given as minus b plus or minus under root b square minus 4ac. This is the determinant upon 2a, right? Then binomial, this is a binomial approximation which we are going to use in waves chapter, I guess. Okay, so if you have something like 1 plus x to the power n, and x is very small as compared to this 1, okay, x is very small, then you can approximate this to 1 plus nx. Okay, you can bring the power down and directly do this approximation. Okay, this sign suggests that it is a approximation, not the true value. Okay, AP, this is something that you have learned. So AP is a sequence of terms, right, wherein the next term differs by a common difference. Okay, so there is some common difference between the terms. Here the difference is d, the difference between this two terms is d, right? So sum of AP is given as, if you remember, it is n by 2 into 2a plus n minus 1 into d. Okay, here AP is not that important. Usually we are going to use GP in our discussions. Okay, and if you are given the last term, okay, you can also use the formula n by 2 into a plus l. Okay, first term plus last term. Okay, and for GP, GP is something which suppose you have, it has a common ratio. Okay, 2, 4, 8, and it goes on. Okay, so if you see the ratio over here is 2, you multiply 2, you multiply 2, 2, 2, 2. Okay, so that is GP. Okay, you multiply by a common ratio. Okay, so the sum of GP of a finite GP, okay, is given as a into 1 minus r, or you can also write r raised to n minus 1. Just flip it over, this will be helpful, I guess. So r to the power n minus 1 upon r minus 1. Okay, either ways it works, but yeah, just for our understanding. So r to the power n minus 1 upon r minus 1. This is for a finite GP. Suppose if we have infinite GP. Okay, if we have infinite GP, of course only those which are convergent, and the condition for that is this. Okay, only those which are convergent will have a sum. So the condition for that, the common ratio, the value of the common ratio should be less than 1. Okay, the value. Okay, so even if it's half, even if it's minus half, the mod of that is less than 1, right? So yes, mod of that is less than 1. So basically your the series will converge. Okay, so this you have to ensure, only then you can apply this formula, a upon 1 minus r. So this is the sum of an infinite GP. Okay, so let's solve some problems, especially on the GP side, so that we get the hang of it. Okay, so you can note this down. Let's move to problems. Test our knowledge on the questions. So here first we are given a quadratic equation. We are supposed to solve it using the quadratic formula. So let's solve it. So x will be given as minus b. So b is 5 over here. So if you want to write, a is 2, b is 5, and c is minus 12, right? Coefficients. Okay, so b is minus 5 plus or minus under root of b square, which is 5 square, 25, minus 4ac. A is 2 and c is 12. Okay, minus 12. So this will become plus upon 2 times a. Okay, so this will give us 4 to 8, 8 and 8 into 12, 8, 12, 96. So 25 plus 96, that is 1 to 1. This is minus 5 1 to 1, the root is 11, right? So plus or minus 11 divided by 4. Okay, so first we'll take it as minus 11. Minus 11 will give us 16, minus 16, or when we take plus 11 minus 5, that will give us 6 by 4, right? So here we'll have minus 4, or the answer could be 3 by 2, minus 4 or 3 by 2. That should be the answer. Okay, so can I check that? Yes, that is correct. Now let's sum this. Okay, so here we are given a GP. As you can see, the common ratio is 2, right? We are multiplying 2. 1 times 2, 2, 2 times 2, 4, then 4 times 2, 8, and that goes on up till 256. 256, if you see, is 2 to the power 8, right? Yes. 2 to the power 5 is 35, 32, 32, 64, 64, 64 is 128, 128 is 256. Okay, so 2 to the power 8 is 256. Okay, now we are supposed to tell the sum of this. Now this is a finite GP, right? Finite GP, the formula is A into r raised to n minus 1 upon r minus 1. Okay, so if you see, the common ratio r over here is 2, right? We are multiplying 2 to each term. Okay, so that is the common ratio. And what about A? A is 1, of course. And what about n? The number of terms. Number of terms, are there 8 terms? No, there are 9 terms. Okay, this is 2 to the power 8, and this is 2 to the power 1. We also have 2 to the power 0, which is 1. Okay, so it is going from 0 to 8. 0 is also counted. Okay, 0 to 8. So 2 to the power 0 to 2 to the power 8. This is the series. Okay, so there are 9 numbers. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8. 9 numbers. Okay, not 8. So 9 numbers. So you have to be careful, okay, when counting the numbers. Okay, so A is 1, R is 2, raised to n is 9, minus 1 upon 2 minus 1. Right, so 2 minus 1, 1 in the denominator, and 2 raised to 9. 2 raised to 8 is 256, double of that, 400, 400, and 1, 1, 2, so 5 and 2, 5 and 2 minus 1, so 5 and 1. Okay, so the sum is 5 and 1. Okay, let's come to this one. Here we have infinite GP. Okay, and you can see that the common ratio is half. Okay, you are multiplying half. 1 times half, half. Half times half, 1/4. Okay, so and the GP goes on and on. Okay, there is no end. It is infinite GP, and you can also confirm that mod of r is less than 1. Right? The value is less than 1, so your GP will converge. Okay, and the sum will be given as a upon 1 minus r. Okay, in case of infinite sum, it is a upon 1 minus r. A is 1, r is half. Okay, so 1 upon half. 1 minus half, half, and that half will go on top as 2. Okay, so the sum of that GP is 2. Okay, although there are infinite terms, the answer is sum is 2. Okay, isn't that fascinating? So yeah, that's the algebra part of it. Now let's study about log. Now discuss about logs. Okay, so log to the base 10 y is given as x. Okay, what does this mean? This means that what is the number the base should be raised to give y. Okay, so what is this number that the base should be raised 10 to the power x to give y. Okay, what is the number the base should be raised to give y. Okay, so when I say log to the base 10,000 is 3. Okay, what do I mean? I mean that 10 to the power 3 will give you 1000, which is true, right? So 10 to the power 3 will give you 1000. That is the idea behind log. Okay, so what is the power to which the base should be raised to give you the input, okay, the y. Okay, so that's actually not important. The properties are more important over here, the properties of log. Okay, so let's go through the properties. Here e is 2.71828. It is a irrational number, so it goes on. Okay, so there are some digits following that. Okay, so you can remember it as 2.71828. Okay, then ln of e. ln of e, so basically log to the base e. Okay, log ln is basically for natural log. Log to the base e. Okay, the base can be anything greater than 1. Okay, that is a restriction on the domain that the base should be greater than 1, okay, so that it can be raised to some power, okay. So here if we have log to the base e, this is also log to the base e can be written as ln, natural log, okay. Ln stands for natural log, okay. So log to the base e, or you can write it as ln, okay. So log to the base e will be 1, okay. Log to the base e is 1, basically means that e should be raised to power 1 to give e, right. So that will be true for any base, right. So log to the base 10 will be 1, or 10 should be raised to the power 1 to give 10, okay. So that is true in general. So log to any base to that, so if you have in general log to the base n, that will give you 1 in general, right, provided n is greater than 1. That is the restriction for log function. Then if we have log to the base e, and if we want to convert between, if you have a log to the base e, okay, and you want to convert it into log to the base 10, you have to multiply by 2.303, okay. So log e, you have to multiply 2.303 to get log to the base 10, okay. So yeah, then we have log of a into b, that can be written as log of a plus log of b. Again, you can use this property to prove this. Then log of a upon b, so in division it's log of a minus log of b. In multiplication you add the two logs, okay. Then log of a to the power n, okay, this property is very famous, you might know it. So you can just get down that n, okay, and bring down that n, okay. Log of any base, and if you have 1 over here, will be always 0, because any base raised to 0 will give you 1, okay. That is the only that is how you can get 1, okay. So log of any base, provided it's greater than 1, raised to 0 will give you 1, okay. So anytime you see 1 over here, log of 1, irrespective of the base, it will be always 0, okay. Log of 1 is always 0. Now here are some standard values which you are supposed to remember. The important among these are 1 and 2, okay. Log to the base 2, log to the base 10, 2, okay, it's actually like this, log to the base e2, okay. It's the value of log 2, okay. This is to the base 10 and this is to the base e, okay. So if you multiply 2.303, you will get 0.693, okay. So that is how you convert. So if you have log to the base 10 and you multiply 2.303, you will get log to the base e, okay. You can try and see, okay. If you multiply 2.303 to this, you will get this value, okay. So these two are the important ones over here, and I would recommend you to remember those two, okay. These two are not that important, but remember these two, okay. So let's find that now. Log to the base 10, and you are supposed to find the value of this, okay. It's very simple. First of all, we will use the property of splitting. So we'll write log 4 plus log to the power log 10 to the power 6, okay. So I'm splitting it. Log a into b is log of a plus log of b. Now 4 can be written as 2 to the power 2, right, because we know the value of 2 only, right. Log 2 we know, otherwise we don't know, okay. So and log to the power, log to the base 10, 10 to the power 6, 6 can be brought in the denominator. And what is this? This is 1, right. Log to the base 10, 10 is 1, so this is nothing but 6, okay. This is 1. Now this can be written as 2 log 10 log 2, okay. So this 2 can be brought down, so this property, okay, you can bring the power down, and log 2 is 0.301, okay. 301, double of that 602, 0.602, so 6.602, that should be your answer, okay. So that is the log of that term, 6.602. You can see that the term is so big and its log is so small. So log is often used wherein you want to express big numbers like this as small numbers, okay. So log is very useful in those applications, okay. So that's about log. Finally, we'll discuss some graphs, and that will be the end of this lecture. Up the class by discussing the different types of graphs that we might see in our discussion in future. So first, let me tell you something about the slope. The slope is also given as tan theta because slope is y by x, right? Delta y by delta x, or delta y by delta x. So that is opposite upon adjacent, which is nothing but tan theta. Okay, and theta is the angle made with the positive x-axis. Remember that. Okay, so the slope can be either positive or negative, or maybe 0 when the line is flat, right? So in the cases when the angle is acute and the line is pointing up like this, the slope is positive because tan theta is acute, and for acute angles in the first quadrant, tan theta is positive. All ratios are positive in the first quadrant. Whereas if you see, if the line is pointing like this, okay, this line is pointing like this is pointing like this, you can clearly see that the angle is obtuse. The tan of obtuse angle, tan when it lies in the second quadrant, it is negative, right? So yes, here the value of the slope will be negative. So here the slope is positive when the line is like this, slope is positive, line is like this, slope is negative. Okay, that is one interpretations you can make up. Now you are often going to see this equation of a line y is equal to mx plus c, okay, in our discussion further. Okay, so this is slope intercept form. Okay, c is the intercept over here. Okay, so c is this value. Okay, when x is equal to 0, the value on y will be c, right? When x is 0, y is c. Okay, so this is nothing but the y intercept. Okay, c is nothing but y intercept, and m is slope. Okay, so if you are given an equation of this type, usually some equations will be of this type, y is equal to mx plus c, you are supposed to recognize those and you can plot it in this form. Okay, now different parabolas over here that may come in our discussion. So first is y is equal to x square, y is equal to x square on face, smile. Okay, so that is y is equal to x square minus x square. You just flip it over, right? Flip it over, make positive, negative. Then x is equal to y square, that is right hand opening parabola, and minus y square, it will be left hand opening parabola. Basically the linear term that is there here, if you see, y is the linear term. Okay, so it opens along the y-axis, opens along the y-axis. Here x is the linear term, opens along the x-axis, opens along the x-axis. Okay, negative x-axis. Okay, so now let's come to this one. This one shows the exponential growth and decay. We are going to discuss about this in decay and current growth and current decay, or charge growth and charge decay during that time. So basically this equation is for decay. You can see that this is exponential fall. Okay, it starts from a when x is 0, it starts from a, and finally it falls down exponentially. Okay, and similarly 1 minus this decay will be growth, right? So 1 minus decay shows growth. Okay, it starts from 0 and it tries to touch a, it touches a in the limit. Now finally the sixth one, we have a rectangular hyperbola. So the equation of that is x into y is constant. We are going to have this in ray optics only once we are going to discuss it, and it's not that important. So basically remember, x into y is constant, okay, for a rectangular hyperbola. So, or x is proportional to 1 by y. Okay, this is the equation of a circle, x square plus y square is equal to a square, where a is the radius of the circle. Finally we have an ellipse. Ellipse, the equation is x square upon a square plus y square upon b square is 1. X is a semi-major axis, b is semi-minor axis. Okay, yes. So that's about the graphs that we are going to discuss. More graphs we'll discuss in kinematics. We have to go into the details of velocity and all, and how to find velocity through graphs and all that requires this basic knowledge. Okay, so that we won't work over here. Okay, that will only touch upon when we go to kinematics. So that's about today's lecture. I hope you really enjoyed it. If you made it this far, smash that like button. Do leave a comment, let me know if I missed something. Okay, and the next video is going to be on vectors. Vectors is a little bit vast as compared to this, and it will stretch out the video, so we'll discuss vectors in the next chapter. Okay, so yeah, that is also a part of maths which is needed for physics. Okay, and it's a very important part. Okay, so yeah, that's about it. And I also wanted to tell you guys that excuse me, recently I was not able to make videos like since I last posted, 30 days have passed literally, and I was not able to post because I was busy here and there. It's the final year of my college, and I just the schedule is just so hectic. I don't get time only. Usually it's from Monday to Thursday we have classes from 9 to 5, but Fridays and Saturdays we are left early. So my plan was that during Fridays and Saturdays I will record the videos, and by Sunday I will edit and upload. Okay, but now since it's the exams are closing in, so we are kept for Fridays and Saturdays for extra class. Okay, so it's Monday to Saturday 9 to 5. Okay, so I don't get really much of time to focus on YouTube. Okay, so yeah, that's the reason I was not able to post. I'm staying up night so I could make this video. I hope you guys really enjoyed it, and that's about it. I would really appreciate if you guys are patient and understand when I'm not uploading. Okay, so yeah, that's pretty much it about it, and I'll see you soon in the next video, hopefully. Till then, keep enjoying physics or maths.